let us now go on to the following panelists, who are Gianella Valencia and Santiago Rodríguez, fellows of the Engineering Institute of the National University. You have the floor, Gianella and Santiago. Thank you very much.
Bien, en esta oportunidad el maestro Santiago Rodríguez y quien les habla
Mr. Santiago Rodríguez will show progress made in numerical inspection. This is with three important objectives. First one, structural behavior. We have to study this behavior in urban concrete buildings according to NFED. And the second recommendation has to do with recommendations for school buildings with particular seismic risk conditions. The third one is to establish possible behavior of school buildings in seismic events in the future. This shows concepts of our research project. This is the design and how structures are displaced. Sometimes they are displaced over the elastic limit, as you can see, and this results in considerable damage. And we have the different designs here for earthquakes that may take place throughout the useful life of the structure. So this damage may lead to interaction and the situation of the building. And this has to do with the anti-collapse. And this has to do with considerable damage affecting the behavior of the building and its operations. Looking at these concepts in an extrapolation, we see that these structures complied with basic performance principles, and this is operational performance, and we have a collapse prevention performance behavior. What happens to essential structures in those schools? Aside from the performance level, we have to protect lives. And we should not be compromising those structures, and this has to do with their original structure. However, experiences show that there is an important percentage of schools with a behavior which is very far from the safety level. And this has to do with the fact that there's a zone of uncertainty where we cannot control the mechanism of structural elements. That's why we should highlight improving those performance levels so that the structures have fast recovery to do away with economic and human losses, because these buildings work as shelters sometimes in natural disasters. The existing structures, this is the retrofitting process to improve performance level. In 2019, a conceptual framework was proposed for the retrofitting of structures based on their functional performance, based on recovery percentages for each one of the phases, short, medium, long term. This timeline will be defined according to the type of structure In our case, we're talking about school buildings and the economic, social, political conditions of the country. These are the buildings we studied: urban concrete buildings, 1 to 3 story buildings, and this 1982, 1988, 2011. These are elongated buildings parallel to the corridor of the building, and there's 3.20 meters. This is the distance. And there's also a distance of 8 meters. And 1 story, 3.20 meters average, 2 stories, 0.40, and 3-story, 9.40 meters. And this is the structural inspection, and this is the way we have the interconnected columns through concrete beams and slabs of different thickness. Generally, 1982, you can see the transversal short direction, and this is the long direction right here. These walls derived from inspections, we found the walls were in contact with the frame in terms of their placement under the windows with the short columns. This is 1988, similar behavior. However, concrete walls were added in the longitudinal and transversal directions. Likewise, in 2011 prototypes, we see concrete walls, but with a better and more symmetric distribution vis-a-vis the shortest direction. And for this one level building, the section of the column was increased and the concrete walls. Later, we will see the implications of this consideration. Material properties. According to complementary techniques, you see here characteristics of concrete. This has to do with the dynamic properties of the structure. 1982 prototypes and the strength. You can see everything on the screen. And this is 1988, 2011 concrete, 250 kilograms per square centimeter. And this is what was used and the elasticity. We also consider this according to complementary techniques that have such an important influence on the calculation of final properties. We defined these elements according to complementary technical norms and standards. For the oldest prototypes, 1982, 1988, additional loads were considered in these prototypes in actual constructions. Seismic demands. According to INIFED norms, R079, this was calculated for 5%, and this is for zone Z, ground 1, and zone D, ground 2, according to the evaluation of those conditions. Seismic demands. According to complementary technical standards for Mexico City, 4 points in the city were inspected, and close to them, there was information of the schools with different damage levels after the 2017 earthquake. This has to do with a percentage of 5% behavior, seismic behavior as well, and the assessment of regularity conditions for longitudinal direction. Irregularity pattern 1 and the transversal one 2.7. Some modeling considerations. Frame type elements for columns and beams, shell type elements for slabs, walls, masonry, and concrete, and rigid or stiff zone factors of 0.5, and flexible diaphragm and masonry walls as well. And we calculated the slab elements as well. This is the result of the modal analysis. This is the longitudinal direction. Here you see the different demands, and you can see the fundamental period right here. And this is the direction for the 1982 one. This was the reduction in this case of almost 0.1. So the elimination of these walls in the prototype of 2011, this is something that was done until the flexibilization process took place. Here we see that in the cases of the 1982 prototypes that are older, we can see the fundamental situation. And Santiago will now take the floor. Thank you. Let us continue with results. Here we see linear analysis as of distortions and between stories or floors. This is prototype UIC, U1C rather, yes, and you can see exactly what is, these are the distortions, and this is in Mexico City. In the 1988 prototype, you see, however, changes in 2011 with X direction in terms of the masonry, as my colleague just mentioned. And this has to do with the increase of the width in D seismic zones. What a flexible structure, 5%. This is only with the limit and the management of that limit. You can see the analysis we made. In practice, there are prototypes built with walls attached to the structure. And we had minor distortions in this case, 1982, 2011, because those prototypes did not have walls. So in terms of the masonry, we're able to have lower levels, lower than 1%. But you can see here distortions under windows and short columns, but the limit levels are not met. Here you see those values that do not indicate those distortions will be reached, but they will collapse. You can see this, which is not over 6%, and these are experimental results in a reinforced concrete column. You can see the reduction, 3%, 4%. Here you can see it on your screen, we had distortions of over 10%. The case of U2C prototypes, distortions are excessive once more. And we can see 1988, 2011, less than 8% distortions. And you can see here no important changes, since this has to do with concrete walls in both directions. And we have data from 1982, with the exception of zone Z, which is ground type 1. Here you see the three-story buildings. These are 1982 prototypes. You can see the difference between 1982 and 1988, and you have the X direction. We have to do better analysis of this because we've had changes and we see slight changes. These are the masonry under windows. This is masonry walls under windows. This is the effect of the module variation on concrete elasticity, level 1, and the main directions of the prototype, respectively, considering class 1 concrete, class 2, intermediate concrete, class 2. When this happens, this is mainly being supplied by an approximate relationship of proximality in terms of the elasticity of the concrete. In 2011 type C, prototype 1, we can see when the elasticity is reduced, when it goes from one factor to another, we see an increase of 68% in distortion. That's why here you see results of elasticity module of concrete obtained through the extraction and in different schools in Mexico City. And this has to do with class 1 concrete. Therein lies the importance of assuring material quality. As you see, this may affect directly all constructions. These are results with linear analysis. And you see the distortions here. This is in Mexico City, U1C prototype. And for U1C prototypes, you can see what happened with these designs in Mexico City. Once more, they all comply. And U3C prototype, with the exception of 1982 with X direction. And then you compare that with more recent times, and you see this is the relations of demand and capacity of U3C prototype 2011. You see how we found structural elements in all three prototypes of 2011 that are not complying with the resistance elements. And you see here 2011, you see concrete walls and the columns that are complying with all the specifications. This is the longitudinal X direction for different grounds. Now, this is the demand capacity relation. We see the masonry walls excessively demanded and in terms of their capacity, and then we have the concrete walls to compare that. These are the U2C prototype 2011. The concrete walls do not comply with specifications for longitudinal direction. And the important thing here is that we have the masonry walls here. And normally the concrete walls, I'm talking about the longitudinal ones. For the case of U1C 2011, we have two different types of columns. When we went from the 1988 design, and we can see the width of the column here. These are the changes that we found, and it does comply with the demand capacity relationship. But in the masonry walls, demands are excessively big. Finally, as part of the work we still have to do, it's nonlinear static analysis with performance points and nonlinear step-by-step analysis to look at the results of the nonlinear static analysis to confirm priority attention levels and determine optimal retrofitting process in each case. Here you see the example of a nonlinear static analysis, the different points of this analysis, conclusions based on results obtained in seismic area C and D of Mexico. Adding concrete walls may be an ideal option for seismic retrofitting for prototypes without walls, without concrete walls in one of their directions. And then for walls under windows are not rigid enough and only fragile faults are induced, and we have a lot of vulnerability. You see in the red and you see the green color. This is a structure which is not so vulnerable. All those of 1982 are in red, as you can see. So we should look at both main directions, especially or with the exception of those in Zone C in 1988, you can see the results. This is the only one we can consider as completely safe until now. 1988, 2011, this is in yellow, located in Zone D, should be rigidized in X direction because they do not comply with specifications in walls and columns. So we would have to have more detailed analysis. And finally, the different prototypes of U1C 1982 and 2011 have no wall resistance, so they are between red and yellow. And it is recommended to do this in terms of the masonry walls and the different prototypes and of 1982 through 2011, because those walls were eliminated. And in the case of the 1988 prototype, it behaved appropriately in X direction. Based on results of the prototype of analysis in Mexico City, most of the prototypes had appropriate behavior because demands in Mexico City are in the order of 4 times less than those in Norm 079 SCFI 2015. So prototype U3C of 1982 direction X is the only one that does not comply. and it is expected this is going to be changed, and these are things we're going to have to look into detail in Mexico City. Thank you so much, Valencia, Mrs. Valencia and Rodriguez. Unfortunately, we don't have much time for questions. There are very particular technical questions. If you could answer them directly for people asking them. Thank you so much for your participation and your presentation.